This is lesson 2.4 and it's on the graph of y equals k times x. So now we're back to talking about direct variation and the slope of a line. So the steepness of a line is measured by a number called the slope. The slope of the line is the rate of change of y with respect to x and can be calculated using the coordinates of 2 points on a line. So in this box where it says slope equals, we're going to write a few ways we can calculate slope to help you understand it. So slope is the change in vertical distances compared to the change in horizontal. You could also say it's the change in dependent over the change in independent. Or you could say it's y2 minus y1 over x2 minus x1. So it's coordinates. It's not just one set of coordinates. You have to have two sets of coordinates. So the slope of the line through the 2 points x1, y1 and x2, y2 is y2 minus y1 divided by x2 minus x1. It's also known as rise over run. So as things change up and down on the vertical axis compared to the run as they change on the horizontal axis. Let's go through a couple of examples so you can see that. Example 1a. Determine the slope of the line with the equation d equals 1/5 t, where t is the independent variable time. So independent, so it's going to be on the x-axis, and it's in seconds. And d is the dependent variable distance in miles, so that's going to be on the y-axis. So t is independent. Independent, and that's going to be the x, and d equals the dependent, and that's like the y. So we could write these coordinates as, since t is like the x, we'd write that first, t, and then d is the dependent like the y, so it's like the y, it's the second one, so td. So now we need to find 2 points to figure out the slope of the line with the equation d equals 1/5 t. So if t equals 10, and I just picked a number, if t equals 10, then d would equal 1/5 times 10. I'm just using this equation here. So d would equal 2. When t is 15, d equals 1/5 of 15. So d is 3. So we have 10 and 2, and then 15 and 3. Okay, now our slope is y2 minus y1. So 3 minus 2. So slope 3 minus 2, and it's x2 minus x1, 15 minus 10. So our slope is 1/5, or 1 mile over 5 seconds. Okay, let's work on the next example. Okay, in this example 1b, it says determine the slope of a line with the equation d equals 5/7 w, where w is the independent variable in weeks and d is the dependent variable in days. So w is independent. So that's like the x coordinate, and d equals the dependent. So that's like the y coordinate. So we could write this as WD. That's our coordinate. Okay, so we need to find 2 points in order to get the slope. So if W equals 7, then D equals 5/7 W, And if W is 7, D would equal 5. And if W equals 14, D equals 5/7 of 14, because I plugged in 14 for W in this equation. So then D would equal 10. So let's write those as ordered pairs. So if W is 7, we said D was 5. And if W was 14, we said D was 10. Okay, let's figure out the slope. Slope is y2 minus y1, so 10 minus 5, and make sure you always do it in the same order. If I pick the 10 on this ordered pair, then I got to do the 14 first on the x. So on the x underneath, it's x2 would be 14 minus 7. So 10 minus 5 is 5, 14 minus 7 is 7. So our slope is 5/7. Looking at the two examples, what pattern do you see with the slope and the equation? Well, in this case, the slope for 1b was 5/7. If I look back to that formula, the 5/7 is the same as the k value, because we know for variation, we have direct variation, we have d equals kw. That's that k value. So the slope equals the k value. And if you look back to example 1a, it's the same thing. The slope is the k value, and that's what they're showing here. Slope of y equals k times x theorem. The graph of the direct variation function with equation y equals k times x has constant slope k. So the slope is k. It's that number in front of the x value. That gives us the slope.